Hi all, welcome to the new video. In this video we will cover the working or operation of buck converter. So buck converter or step down converter, as its name says, it step downs the DC voltage. That is, the output DC voltage will be always lesser than the input DC voltage. So this figure shows the circuit diagram for a buck converter. It consists of two switches S1. S1 is a power semiconductor switch. S2 is a diode. Then we have inductor, capacitor, and then the load. So the average output voltage is always lesser than the input voltage. That is why it is called a step down converter or buck converter. This figure shows the representation of buck converter with the help of switches. Here the switches are S1 and S2, which are considered as SPDT, single pole dual throw switches, and then inductor and capacitor. The two switches are S1 and S2. So the first case or first mode of operation is the circuit working when the S1 is closed and S2 is open, and this time period, this duration is called D into TS period. And the second figure represents the switch S1 is open and S2 is closed, and it is represented as 1 minus D into TS period. Okay, for the TS is a total, TS is the total time taken for a complete cycle. So before we are going to discuss about the operation of buck converter, we have to consider the following parameters. They are voltage across the inductor, current through the inductor, load current, current through the capacitor, input source current, voltage across switch S1 and S2, and current through the switches S1 and S2. These are the waveforms of various signals of a buck converter. So in this waveforms we can see different time durations like S1 on, S2 on. During the switch S1 is on, that is represented as D into TS. During when switch S2 is on, it is represented as 1 minus D into TS. And then it repeats. And the waveforms are voltage across the inductor, it is represented as VL. Current through the inductor represented as IL. Then the current through the capacitor represented as IC. Then the input current through the switches S1 and S2. Voltages across the switch S1 and S2. So these are the different waveforms represented here in this figure. These are the waveforms of various signals of the buck converter. During the DTS, during this duration D into TS, switch S1 is on and S2 is off. So the voltage VL across the inductor during this time is VI minus VO, where both the quantities are DC quantities, and hence VI minus VO will be a DC quantity. And therefore the current through the inductor is given by VI minus VO divided by L. VL is equal to VI minus VO. And therefore the current through the inductor is given by VI minus VO divided by L. And for the duration D into TS, we have to take the integral of this, all the values. So it is given by integral of over this duration, integral of voltage through the inductor into dt. So it is given by integral VI minus VO divided by L into dt. So taking that 1 by L outside, we will get it is equal to 1 by L integral Vi minus Vo into dt. So finally we can write Vi minus Vo divided by L into integral of dt. The reason is Vi and Vo are DC values and L is the inductance. So these are constant values, so we can take these values outside. During 1 minus d into Ts time, during this time, when S1 is off and S2 is on, the voltage VL across the inductor during this time is minus VO. During the 1 minus d into Ts period, switch S1 is off and S2 is closed. And then the voltage across the inductor cannot change instantaneously, but it will be start decreasing. So what happens is, it is Vi minus Vo. Voltage across inductor is Vi minus Vo becomes negative. The reason is Vi becomes 0. So VL is equal to 0 minus Vo. That is equal to minus Vo. Therefore, the inductor current IL, which is equal to minus Vo by L. During this time, the current through the inductor will have two components. One is the AC component, another one is the DC component. DC component is the DC power supply. DC component is the DC power which is available in the circuit, and AC component is formed because of the stored charges in the inductor. So the AC current will go through the capacitance and the DC current will go to the output. So the capacitor current or IC will be the inductor current minus the DC current. That is, IC will be equal to IL minus IO. Now we will see the steady state analysis of buck converter. That is the input output relationship. The input output relationship under the steady state conditions can be obtained by some ideal constraints. That is, we have to consider the following parameters. The switch S1 and S2 have no on state drops. That is, the on state resistance of S1 and S2 are 0. The second point is, the winding resistance of the inductor is 0. That is, the inductor which is present in the circuit exhibits no losses. Third point, the equivalent series resistance ESR of the capacitor is also 0. The capacitance also provides no resistance. And the final point is, there are no losses in the converter, implying that the efficiency is 100%. That is, these are the ideal constraints. Looking into the input-output relationship, from the figure of waveform, the average current in the circuit will be 0, because during both these durations, that is d into Ts and 1 minus d into Ts, we can say that Vi minus Vo into dTs, that is during dTs, the current during dTs, plus minus Vo into 1 minus d into Ts. This is during the 1 minus d into Ts time. So during these two conditions, the total current will be equal to 0. So simplifying this equation, simplifying means expanding these equations and simplifying. So what we have to do is, Vi minus Vo into dTs is expanded, then Vo into 1 minus dTs is multiplied. So finally we get Vo is equal to d into Vi. Okay, therefore d is equal to Vo by Vi. And then this duty ratio d will have values between 0 and 1. The reason is, the output will not be greater than input, and that is why it is called a step down converter. Similarly, the power transfer Vi into In is equal to Vo into Io. Using these equations, we obtain I in is equal to D into IO, substituting for VO. Now, these equations has to be memorized. The value of inductor is given by L is equal to VO into 1 minus D divided by delta IL into Fs. VO is the output voltage, D is the duty cycle, IL, delta IL is the change in the inductor current, Fs is the operating frequency, or 1 by Ts. Now, the value of capacitor is given by C is equal to delta IL divided by 8 into delta VO into Fs, where delta IL is the change in the inductance current, delta VO is the change in the output voltage, Fs is equal to 1 by Ts. And we have the expression for delta IL. This delta IL is called current ripple, and that is equal to VO divided by L into 1 minus D into Ts. Similarly, delta VO is called the voltage ripple. It is equal to VO by L into 1 minus D into Ts square by 8C. So this is about today's session. If you have any doubts, you have to clarify during the online class. Thank you.